Hello again. So we are going to continue with the linear relation, but instead of using table of values, which is very useful at times, but not all the time, we need to be a little bit more efficient so that we can graph a given data very fast or a relation using the equation directly. And before doing that, we need to actually know the components of a given linear equation. So first thing first, slope. We need to know what the slope of a line is. And definition of a slope is very simple. It's how steep the line is. So, and the steepness of the line is that slope. And it's a numerical value actually. It's actually a fraction, a ratio, and I'm going to talk about that. But couple of things just before that is that first, if you see a line, and if a line goes from left to right, so going from left to right, all right, and for example this one right here, this one going left to right, you always look at from left to right. And if it's going upward, so going upward right here, oh, so this is going upward or uphill, you can call it uphill like that. All right, if it's going uphill, then the slope will be positive value, whatever that the slope is. I'm going to talk about that. If it's going downhill from left to right, so look at the second one right here. This one is going downhill from left to right, so it's going downhill. So let's write down as downhill. The slope is negative. Now remember what I said, you're looking from left to right. That's the only way you can distinguish between the two. Okay, and the letter that we represent a slope with in the equation, the letter by convention, we call it m, because we're going to write a slope intercept form of a line as an equation, and you need to know that. All right, now here's another. So the next piece is the definition of a slope. And definition of a slope is when you go from left to right, doesn't matter how you do it, but it's always slope is rise, the value how far up you go, and then you go across and you hit the line again. This is the rise value, and the horizontal distance from the place where you go and hit the line, that is called the run. So the fraction rise divided by run, or rise over run, that represents the slope of any line. Okay, and remember, if it's going uphill from left to right, it's positive because you're going up, so that's a positive value. You're going to the right, remember on the regular Cartesian coordinate, right on the x-axis is positive, up is positive, right? So if this is the y-axis, that's up positive, and left is negative, and down is negative. So rise over run, if its rise is up, you're going upwards, that means that's positive value for the top of the fraction, for the numerator. And then for the run is the x value differential, and if you're going to the right, that's also positive. So remember that the vertical value is the y value. So that's the difference of y value. We call that delta y, or change in the y value. So in this case, it went from 0 to, let's say, 10. If this is 10, I'm just making this up, then the difference in the between 0 and 10 is 10 value. That's what that is. And then the run is the difference or change in the x value. And the same idea happens. So if you go from here to there, so we're looking at, this is the you can count it actually, right, using the graph and then go from there. But if you can do that, then you can see that the difference between that point and that point, whatever is in between, that would be the value of the x, and therefore another way of writing this is delta y divided by delta x, and that's basically mostly the notation that is being used in sciences like physics and chemistry and stuff like that. Okay, the next piece of the linear equation is y-intercept. In fact, we can deal with the x-intercept as well, but don't worry about it right now. The x-intercept is very simple. If I draw any line and the point of intersection of the line and the y-axis, which is right there, that is called the y-intercept. And the y-intercept has always the x coordinate is 0 and the y coordinate whatever that it is. In this case, let's call that b, whatever it is, whatever that value is. All right, but always the y-intercept is when the line crosses the y-axis, that coordinate is the y-intercept. And sometimes the y-intercept, you can say the y-intercept in terms of the coordinate ordered pair, or you can actually say the y-intercept is 4 or 10 or -4, whatever that is. By the way, you could have a line that is the other way, doesn't matter. Let's go like that. This one, line 2. What is the y-intercept there? Same idea. You look at the intersection point of the line and the y-axis. So remember, that's your y-axis, that's your x-axis, horizontal and vertical, and that's what will be. Now, what do you think the x-intercept is? Same idea, only now you're looking at when the line crosses the x-axis. So in here, that is x-intercept. All right, and basically that's what that is. Very simple. All right, so make sure that you know how you can kind of see the x-intercepts and also know how to figure out the slope of any given line.